Welcome to our crop weather outlook for this year and beyond. I'm Elwynn Taylor, climatologist at Iowa State University. Our question is, what will be going on with corn and soybean as we look ahead? Both crops are sensitive to the soil, to the fertility, to the light, to temperature, to day length. All of these things are factors that we are concerned with. And both of our crops, the maize and the soy, are sensitive to these things. A major effect west of James Bay is what we call the Chinook winds. That is a major effect, at least in winter. It is an effect that we have when air passes over a mountain. You can see a little mountain kind of in the upper third of this picture, and it says condensation value in this gray. As air passes over this gray mountain, I saw a little arrow going up there, the temperature cools with elevation. Basically, it cools a couple of degrees for as we go up in elevation, let's say for, a typical mountain that we might go to when we're in the western portions of Canada. And at the top of the mountain, we'll have cooler conditions and condensation. Clouds often form as air lifts over mountains. And as the air continues to move on the screen from the left to the right, it will begin to descend on the east side of the mountain, and air warms as it comes to lower elevations. When this happens, this is known commonly at least in North America as a Chinook wind, the warm, dry air coming down off of the mountains and often expressed as a warm front. Moisture that was in the air disappeared as it went over the mountains and came down on the other side as warm, dry air. This will often reach into perhaps Western Ontario. Manitoba commonly has a Chinook effect. The North American Drought Monitor has been expanded beyond this old picture that I'm showing you to a new one that you can get. And you just go to droughmonitor.unl.edu/NADM/home.aspx, as you see on the screen. And this will give you a picture, in this case, of the 48 states, plus at the bottom, other states of the United States. But this is also now available that shows both Canada and the US. It follows the 48 states of the US all the way up through the provinces, and then to include near the Arctic Circle and over to Alaska. All of these things are available in the North American Drought Monitor. This is another factor that we look at, and I'm using some older pictures here because they're dynamic and show the 8 to 14 day weather outlook. It's not a forecast, it's an outlook, and the things that you might expect from the way the weather is set up at the present time, or at any present time. This example that was given from 2016 showed warm conditions over the 48 states. I was unable to get a picture at this time that included the provinces, but they are available. And I hope to have one in today's presentation, but wasn't able to get it. On the right-hand side, it shows the 2-week precipitation outlook, and the left side of the screen shows the 2-week outlook for temperature. When we look at the outlooks, and I'm sorry on this picture, I could not get a current one for some reason today on my computer to show the provinces, but the picture looks the same as it includes Canada with the US. And you can look at those when you go to this MSET case that we're looking at and is at the bottom of your screen. For a long time, people have understood that the sun appears in different places according to season. The moon does as well. For the moon, it would be 18.6 years if the moon showed up where you see the sun coming up through this picture of Stonehenge, by the way, in Britain. And if you were seeing the moon at exactly that position, it would be 18.6 years until it did it again for the same time of the year and so forth. That's just the way things work, the moon working a little bit different. We do have, talking about the moon does have an effect on tides. Here's a picture taken in the southern United States, down in Florida, of flood conditions, high tides due to the gravity effect of the period of the moon as it's related to the Earth and the sun and the gravitational system that we have. We also have available what we call wind roses, where the winds are coming from. I'm just showing an example here of one in central Iowa for a time of year. And this time of year, we see the winds are primarily out of the northwest. When you look at the wind rose, which we have here and are available for many locations throughout the US and the provinces of Canada, and you can get various seasons. You can look at the season for, in this case, still in Iowa, using it because that's where I happen to be. And these examples giving the southerly flow of the air, and when we're in the summer season, the northwest flow of air when we are in a winter season. So the wind, the prevailing winds change with season in most portions of North America. And it's certainly true with Ontario and Quebec and over Manitoba area. I put several of these that are still in the Midwest. I apologize for this because I couldn't find some for Canada at the moment, but I know that they are available. We're looking at windrose, rose spelled like a flower, the flowering rose, and how the conditions change with the season for the winter and for the summer in this case. At the bottom is in the state of Nebraska of the US, from prevailing winds on the left from the north for winter, and the summer from the south. These will vary a bit depending on the province that you're in, but still the windrose will work out about the same. Often winds shift with the time of day. I'm using here an example of data that I happen to have for a small community near where I am in Iowa. And as we go through from June at the lower part of the collection, the red dots, and approach May, we do get wind speed increasing, mostly because of the time of year that we have the winds that vary with season. This is a common thing for winds to vary with season, from the prevailing winds determined really by the whole continent itself to determined more locally as we get into the warmer times of summer. And you'll see them for different cities having slightly different pictures. This is an example that you can see when you go to latest_cmol.gif. It will give you a current picture of the planet. The sort of stretched out in an interesting way so that you can see what's going on for the entire globe. Of course, we can't see the poles just because they're angled. This emphasizes going along the equator. You can see in Canada the colder temperatures at -25 when this picture was taken on the 5th of January in 2017. This is available to you from satellite when you go to this website, latest_cmol.gif. These are produced by the University of Wisconsin in the United States, and of course for the world. This is a cooperative project. It includes data from Canada and from most of the nations associated with us, at least with the United States by treaty. And this makes for meteorological exchanges that work very well. I think we have almost unanimous agreement from around the planet for weather information to all be made available to everyone. We know that at certain times, certain countries may block out things because they've got a weather sensitive thing that they consider international might cause trouble, but for the most part, people are cooperative in this global picture that you are seeing here, produced by the University of Wisconsin and available to the public at the website that is shown at the bottom of this picture. Cold conditions with a low pressure over in Quebec, and the cold air coming down in the center, probably Manitoba and over into Saskatchewan has the definite cold air in this picture coming down blue. And of course, this was a picture that was taken in January of 2017 and used as an example in this case. Just to look at a different picture, and I'll move back to the first one and then back to this one, you see some variation from the 5th of January to the 3rd of February, in that the warmer colors have begun to move up toward the Great Lakes area of the United States and Canada, and the very cold area has retreated up into more the territorial area rather than in Ontario or in Manitoba or Saskatchewan. You see the deep blue retreating up into the territorial areas. These are good views that we have, and these are available every day, twice a day at least when the satellites are all working. Satellites have become quite reliable. They're an international effort, and especially these projects were developed mostly by Canadian and US efforts. The work was done at White Sands, New Mexico, by the way, because they have control of the satellites that we get the basic information from, but all weather information is available to all countries on the planet. And an example of what is going on at the equator with the continents blacked out and showing temperatures that respond to the ocean temperature in shades of orange. I put a circle south of North America to the west of South America that shows a point of interest in this sake, we see along the equator, blue, that is the cold temperatures of the ocean, and looking at along the equator of an area of air circulation. And we have the higher areas with the difference from sea surface temperature and different temperatures that we see over the sea, varying from the cold temperatures in the blues to the warmer temperatures, maybe 2 or 3 degrees Celsius warmer. These are indicated as degrees Celsius on the scale below. And so from 5 degrees of warmth with the dark reds that you see really none of in this picture, and quite a few of the yellows and the oranges, particularly off the east coast of North America. This may have an important impact on Nova Scotia and the New Brunswick areas, but over and into Quebec and Ontario, the effects of what's going on at the sea do not commonly a large effect, especially in the winter. But still, the analysis is there for what's happening at the global scale. I showed here some different ones as things change with season, particularly look up toward Nova Scotia, and you will see things considerably warmer just off the coast. This is the remnant off the east coast of Canada. This is a remnant, the warm Gulf flow of sea surface water coming from the Gulf of Mexico up the east coast of North America and having quite a temperature effect when we reach the Nova Scotia area. The days with precipitation a year usually varies with season. This is just a typical example of what we have in the Midwest. And the days with measurable precipitation varies a bit as we go from south to north. But for the most part, we see the important thing is that the trend has increased from Ontario and Saskatchewan all the way down to near the Gulf Coast of the Gulf of Mexico. But I look at the data of the southern United States, but not all the way to the Gulf for these days of rain. That would be, I would include in this, would include Tennessee and Kentucky and Indiana and Michigan and up to Ontario. And the number of days of precipitation varies with the weather station that we're looking at. The important thing to realize is that from 1893 and I'm sorry, it's gone off the edge of the screen, my calibration error here, but an increase in precipitation for the continental states and clear up into the territories has increased as we have moved from 1900 up to the present time. Days with measurable precipitation, in this case, down for the state in the United States of Iowa, has increased from 70 days with precipitation back in around 1900 to closer to 120 days with precipitation when we get to current times. This is just for one city, and I'm putting it up as an example. This is the city where I am sitting right now, Ames, Iowa, and we also see some increase in precipitation that has gone on in the center of the continent, all the way from, I'm not going to include Texas and Arkansas in this, but all the way from Missouri up to Iowa, up through Minnesota, and up into Manitoba, and Ontario. We get this precipitation typical of the pattern that you see here. The numbers that I've given are for the city where I am stationed, which happens to be Ames in Iowa, very close to the center of the 48 states of the United States. And the pattern is very similar when you get out of the effect of the Great Lakes and up into Manitoba, Saskatchewan, Ontario. We see a pattern similar to this. Don't pay attention too much to the number of days, just that it increases often as we've moved along. The amount of precipitation is a curious thing. We have the high precipitation where it's affected by the Gulf of Mexico, and we've had a significant increase in the United States precipitation since 1950 through 1993. And this is an important thing. And I'm sorry that I don't have the picture that extends up into Quebec and Ontario, although the data do exist in Canada. I didn't have it available when I put together this slide. So the upper right hand side of this picture is lacking, but you can see the consistency as we've gone north through the Great Lakes up toward the Ontario area, and how it I see there when we're looking at up toward Thunder Bay, that we have things becoming very much less intense than we had down on the south side of the Great Lakes. There's been an increase in flood-prone years in most of the 48 states. I do not have the data for Canada, but I know that it is similar for near the US border. One of my Canadian friends said, I don't know if this applies. Exactly where are you? He said, it applies. My home in Canada is about 30 miles directly south of Detroit. And so sometimes I have to wake up to the fact that Canada extends further south than the US state of Michigan. But and these data should apply there. I am using here the example of where I live, of how the corn yield has increased since 1925 to 2010. But the point I want to make applies to everyone that's not on the immediate coast of the Atlantic, the Gulf, or the Pacific. And that is the increase we have seen in maize yield. Listed here as corn yield because people in the United States think corn means maize. The yield of maize back in 1940 being only 1/4 or even less of what it was in 1970, and then it doubled again from 1970 to the present time. The dashed line that you see is my idea of connecting the high years that we have and what the path is for corn yield. And this yield of maize going on is typical also for, as best I can tell, Ontario, Manitoba, and Saskatchewan. We have seen a similar pattern. The yield given in this case in bushels per the acre on the left are not the same units, but the same relative picture seems to go on. The corn harvested in the United States, you see, is heaviest right where I'm at. in Iowa, which is why I'm in Iowa. I was raised out in the no corn significant western central United States, northern Utah. And I moved to the Midwest because I was interested in grain and grain production. I'm sorry I could not find a picture that showed the map as we went into the Toronto area, but I suspect that Toronto and up to Ottawa are very similar to what you see if you just sort of imagine what goes on between northern Michigan and northern New York states. Would be at least typical of the high agricultural production of Quebec and Ontario, at least from what I understand. This is a picture of the graph made by a farmer in 1885 of the dry and wet cycle, he called it. It begins at the left in 2010 and proceeds to the right with years that were just booming for crops and had panics some years with such as the second very low point on this being what we would call the Dust Bowl years of the droughts in the United States. And we have the boom years, we have panics, we have all of these things that go on. And this chart for grain, what I have here is taken out to the year 2000. And with the ups and downs that we have of production and of maize is for the most part we're looking at here, but it does have an ups and downs of the weather cycle that are very, very definite and going on. And we, of course, are due for another low point as we come into the next few years. This was history for the farmer that made this graph, where I've divided the graph. This was the history he made it from, and everything to the right of 1890 was his guess, and because he thought it would be a regular pattern. And it has turned out to be within plus or minus a year all the way up to the present time for this climate effect that we have is known as the Benner cycle, after the farmer Samuel Benner that wrote this in 1885. So this chart was found more than 50 years ago, and it has been a very interesting thing to realize that we do have a pattern in our weather as we move across the country. The Dust Bowl, it was the years of extreme drought in the state of Oklahoma, south landlocked area, far away from water of the 48 states. So this was the Dust Bowl years that affected there, 1932, where I have put an arrow pointing down, which was very bad for Oklahoma and Kansas and Nebraska of the United States, and pretty bad for really the maize production center of the nation, which would go almost over to Chicago, perhaps to Detroit, Toronto area. I don't think that I don't know what the effects were when we get up to Western Ontario and Manitoba. I do not have those data, but the pattern has continued, and I think it will continue if you want to look at it that way. that we will have the years of hard times where we're down at the lower areas, and of the booms. I did cut the chart off before I got to 2004, but I have been watching it since that period of time. And indeed, the pattern does continue. This farmer by the name of Benner did figure this out with that early chart, and that it would be likely continue with the same pattern, which isn't perfectly the same for each drought year, the bottom of the chart, or for each boom year for production, the top of the chart. But the point where these things reach the what he called the boom level for markets and the panic level for the markets at the bottom, and the graph that you're seeing is really the market condition. That's why he called it panics and booms. It's how it affected the grain trade in the U.S. Grain trade mainly being maize and wheat. I put the periodic impact for the middle of the 48 states, the United States, and you can see the very repeated things that I've placed in here with these little oblong marks along the chart, with something going on in every 18-year period, where we anticipate once we get through that, things will get better. The one exception to that, just but a couple of years, was in 1973, but then we seem to get right back on the track that came as a drought, and this is for maize. At the top of this chart, it says IA corn, meaning the state of Iowa, and people in the United States think that corn means maize. The Farmer Benner's chart, one of significance. I put it on a chart of just by color codes for every year and what happened to the production up to 1993 and down to 2000. And this has continued. I haven't filled it in the chart, but the risk continues with the favorable years above the arrows, and some of the less favorable years below them. But you will quite often see that we go through a boom, and then we go through a bad year, and these are in the cycles, and the cycles work out with this chart pretty much to fill the one that we just saw before. Weather volatility, climate risk in agriculture is likely to be greater during this next 20 years than during the past 20 years. There will be greater risk for production of crops, and that makes the management of risk, or risk management, more important during this coming decade or 2 decades, just because there seems to be, well, there definitely has been in the past, an 89-year cycle of our weather. And with this 89-year cycle, the very worst year in the 48 states for crops in the early part of the cycle was 1846-47. The next time that was that bad was 1935-36. The next time is into the 20s, 1847, 1936, 2025 will be what will likely be the most volatile years. And I don't know if this will affect eastern Quebec. I don't have enough data there, although I keep thinking I should. I haven't been able to find it, but will definitely influence Ontario, Manitoba, and Saskatchewan, at least the eastern half, from Regina to the east. That's about the way that these things have looked to me. We sometimes standardize the picture for the index that we have, the January, February, March season, and it gives us an interesting picture. The tree rings give us the 19-year cycle as well. Here are the number of locations where the growth rings of trees. You see when you cut off a tree trunk and look at the horizontal surface of it, you'll see the annual growth rings of the tree and the number of stations that were in drought and the number of stations where the trees were observed that were not. And we can see the pattern that was, we'll say, in 1880 became harsh following 1860s harsh time, and so these things go for the number of tree areas where the trees historically showed drought. Going back through the grain records that we have, these also followed these tree rings indications very, very closely. The trees, of course, have a slower response than an annual crop because a tree is anything but an annual crop, but it is the way that I get long term in one site is by the trees that grew there. And so you can see the number of stations that were having a dry period, the number having wet periods, the number of droughts that we were having as we went through the serious times. And things, the wet times, the dry times, that and the number, the extent of the dry times. And if you look since the late 1890 perhaps, up to the present time, we've had more consistent number of stations showing us the number of droughts. Drought stations have sort of leveled off at 20 to 30, but we do have increasing adversity that we went through to 1847, decreasing adversity to as we came in more mild conditions, and then we were right back again after we got past 1936 to another wet cycle and so forth, that we're getting a little better idea on this picture. And as you look over to 1990 on the right side of the picture, we're seeing the long-term effects. Stress be increasing, should reach its peak in 2025. I don't think it will be as bad as the very bad one that we had back in the 1800s or in 1936, which was the top one on this chart. And then these are the number of sites, but where the cycles have been, and the heat stress. We're at its increasing peak right now. And as I said, 2025 is expected to be the peak. I mentioned already that the really harsh years, 1847, 1936, 2025, if the weather continues to do what it has done for the last 300 years. A little better picture of just what these things look like when you're looking at the tree rings. This includes the Jamestown colony of Virginia and Roanoke Island areas where this happened to get these trees and had some history there. And so that's why I used these. The lost British colony is in the lower left-hand corner of the picture. It says the lost colony Drought is in 1587 to 1589. The lower left extremes are the closest things are of the tree rings. Then the trees did very well in the middle of the lower left tannish picture. And then we had the Jamestown drought of 1606 through 1612 in the lower left-hand side of the picture. And after 1613, we had a very good year at the right-hand side of the lower left picture. And we continue to go through this cycle. There's tree rings, growth rings, annual growth rings of trees are our real record for what went on. And this is about the closest thing I could come to for the eastern United States. And I didn't have any data for extreme eastern Canada, but at least this gets us up to the area of this, well, at least as far north as we have for Lake Ontario and Lake Erie areas. The 800-year rain in Virginia indicated from the tree rings. And we see at the bottom the orange offset that I have and up to the year 2000, and that this pattern does continue. And as I already mentioned, the dry years, we do anticipate that we will have our next seriously dry year is almost due. 2025 would put it right on the schedule, if we could say those things will be scheduled. Remember, the bad years were 1800s, 1900s, and up till now, 1847, 1936, and 2025. And so you can see the 1936 one on the upper chart. You can see is that last really low area on the chart in the white area of blackened was the what we called the Dust Bowl. Dust Bowl caused because of the high temperatures, low precipitation, and poor care of the soil, by the way, is why we got the dust. And the Dust Bowl of the United States was basically Oklahoma and Arkansas and Kansas area. So kind of that triangle. And we hope that as we come to the extremes again, that which may be 2025, that it wouldn't be a Dust Bowl because we take better care of the soils than we did in the previous years and epochs, but maybe a similar pattern with climate. We hear about El Nino and La Nina. The extremes in the northern hemisphere, at least of the United States and Canada, the extremes are with La Nina, and El Nino being the gold, La Nina being the purple. I'm sorry I don't have all of the things that I would like to show you because I didn't have the data readily available for Canada, but I am confident that you will see very similar things in the maize and the soy production areas of at least the western half of Quebec, most of Ontario, especially when you get away from the lakes, and as you go over all the way out to Saskatchewan. It's about what I have chosen to talk about today. In summary, we do anticipate that we are in the cycle right now that we will have 2025 likely be the most extreme year that we have of this part of the 89-year cycle. I'm happy to entertain any questions that you might have.